Awesome. Can you guys hear me? Perfect. Hey, so I'm Fabian. I'm the co-founder and CEO of KYVE Network. I am a software developer and got into the crypto space in, it was end of 2019, early 2020 actually. And I started out in the KYVE ecosystem. So I was always working with data storage and everything. And then I kind of got torn into the whole KYVE Network story. We're going to talk a bit about that. And basically what we're doing with KYVE is we are building a fully decentralized data lake. It's going to be very quick and easy talk, quick introduction to KYVE, some milestones, why we are building a decentralized data lake and why it's so important, and then just some question and answers if you guys have any. So right now there are a lot of fundamental problems when it comes to data management and data storage in Web3 and on a blockchain specifically. And the main problem to it is actually that data is pretty condensed. So first of all, quick question, who of you guys is a blockchain developer and has worked with data storage? Not too many. All right, that's perfect. So basically think about it the following way. You're building a company, right? And this company has to keep track of every single record they are doing on paper, print it out, put it in a warehouse. And after a while, if you're a successful company, you have this huge warehouse where you have to manage, well, tons and tons of paper, but there's actually no use for it, right? Because the only use you would have is, well, for some auditing cases, you might pull them up, but basically it just costs you a lot of money to maintain all of this warehouse and make all this data accessible in case someone needs it. And then it's pretty obvious what happens next. It is basically lowers your profit on the whole thing, right? And the least thing we want to happen is companies kind of lowering profit just for kind of like some auditing purposes. That's like a very easy example of like the current blockchain space, because what all those blockchain networks do, and I think Solana is a pretty good example of that, is they are highly decentralized actually on the block creation process, but then actually storing the data just gets way too costly for them. So what they do is they start pruning the data and start deleting the data, and you actually run to the risk of centralizing data availability again to a point where actually for Solana I think it is quite a case where there's one public archiving node to get all the data from, and that's the Solana Foundation itself. So we're actually running into a centralization problem if we don't start building some secure places for networks to offload their data into, right? And then it's also quite tricky to, well, retrieve all those large amounts of data, because how do you actually do it? There are multiple solutions out there. There's the graph, that's quite famous. For GraphQL access, dual analytics, for analytics purposes, but the problem is they actually all don't work with the native data. So basically what they have to do is they have to build their own custom indexing services that takes the data from one place, puts them into another, so you also run into the risk that there could be some malformed data. So how do you actually make sure that you're also working with the correct and valid data, right? And then it also comes into that if you're a developer, there are tons of different, well, data applications and data use cases you might even have in one app. If you're building like a profile page, a normal database is fine. If you're maybe building something with insurance, you need some more high-end data stack. But how do you really do it in Web3? And currently there is no solution to that, right? There's also no way to cache state transitions. And what does it mean? It means that if we're working with a smart contract, what's going to happen is that if I transfer a token from A to B, I'm actually just subtracting my balance by 10 and adding it to B's person by 10, right? And if we want to replay that and actually get to the current result, it's a very kind of intense computational cost you have. But the problem is you cannot really cache it. Caching meaning you can store it in a different place, because then how can I trust this cache that it's doing a correct job? And actually then we are kind of like starting to build, this is a bit what's happening right now, like a 2008 financial situation, but for blockchain infrastructure, right? Because what's happening is right now we see a lot of like hacks on bridges, hacks on ecosystems, because the underlying infrastructure isn't really supportive enough for everything that's going on. And so basically we can actually lead to a huge collapse in the whole market if we start kind of stacking up more and more and more insecure systems on top of each other that deal with like some centralized points in some parts, because this is just a very easy, very important attack vector for them. And also the cost of distribution is crazy expensive as well. I mean, the only reason why we don't store NFT metadata on-chain on Ethereum, for example, is because the cost of storage is the most expensive gas code, right? And this is because for computation, it's easy. It's a one-time thing, and I have the new result. But let's say you have your NFT and it has a, I don't know, an ape image. You have to carry this around forever on tens of thousands of machines to keep it really truly decentralized. So you cannot really optimize for computation in one part, but then data storage on the other part, because they are conflicting with each other, right? So that's kind of like what the EVM model is, and why, well, actually so many NFTs are stored on Amazon S3 or something like that, because you just cannot simply afford storing all this information in your smart contract just by pure design, right? It's pure design choice that this is impossible, because you don't want to start carrying around data forever. And this is until then we have Arweave and IPFS and like file storage optimized blockchains kind of coming up that allow us really to now build the infrastructure of a fully decentralized data lake, making it then accessible kind of for everyone else to store the data in one place and then being able to access it. And so the whole KYVE story is kind of like a very organic thing, actually. So me and my co-founder, we were working on like a Arweave KYC project, and then one day came across a grant from Parity and Arweave to store Parity's data onto Arweave, because they realized this exact problem. We're like, oh, we have to find a way to kind of offlay our data to a different place where it's more optimized for data storage, because we know in the long run we actually can't afford it. And that's then what me and John, my co-founder, built out. And then we started realizing that actually all of the other ecosystems have the exact same problem. I mean, all of the EVM ecosystems do have the same EVM design problem, right? And there is not a real solution to anything, because even in Web 2, right, there are multiple reasons why you would choose this database over that database. It could be because you're more familiar with that. It could be because this fits kind of like your choice. So it's really kind of dependent on where does the developer build in the end. And then we started reaching out to all of those layer ones, kind of like secured their initial support, started building out integrations for them. And then it got really, really interesting, because then we also came across actually data providers like Chainlink, like the Graph, and realized, well, actually, they have the same problem as well. How do they get the data and then monetize it? Like, how do they actually get the initial data, and how do they make sure that the data they work with is valid? Because just imagine the economic damage that happens if Chainlink would put up an incorrect price. I think it happened for the whole UST story when that thing went down and Chainlink had to stop, right, the Oracle service on other EMMs. The price just crashed because suddenly you were working with incorrect data all over the place. And so it's really, really important that we make sure that valid data and accessible data stays the base layer of all crypto transactions, because otherwise, in the long run, it's just going to all going down. And so this is how the whole KYVE story came along. And basically the way it works is that KYVE fetches data from any data source. In this example here is a blockchain, stores it on permanent storage, like Arweave. We also support other storage backends like Makina, Filecoin, and so on. And then making this accessible in a raw form, really, to all projects out there. So like the Graph can utilize it, KYVE can utilize it. You can utilize it in your application. If you're building an NFT marketplace, you can actually store the data through KYVE on permanent storage, and then having this accessible in your application, because you know that the data you'll be working with is actually correct. So the way this works and how we ensure that data actually stays valid is a proof-of-stake system. So we have two types of nodes. We have a Cosmos SDK-based chain that handles all the consensus. And then we have protocol nodes that are relaying the data via runtime. And the runtime can really be anything. It can be getting the data from, well, Near onto Arweave through KYVE. It can be actually decentralizing data. We actually have a cool use case in discussion right now where there's a platform from Region Network, and they have all this weather data that is a public good but centralized, and they want to make sure that this data stays accessible. So how do they solve it? And this is how they approached us and saying, hey, we kind of need to get this data decentralized. Can you guys help us with that? And that's actually what we're doing there. So we have a storage pool. This one is executing all of the runtimes and is handling the data relaying. And the storage pool requires a project to fund it. And then the funding gets paid out over time as staking rewards to the validators and to their delegators. And what's going to happen is if a storage pool ever runs out of funding, it pauses. And so it doesn't relay data anymore. And of course, then you're kind of in this critical phase. If you're building like an analytics tool, for example, on top of the data, you're always, of course, incentivized, right? Purchasing KYVE tokens, putting it up in the pool as funding to ensure that the system keeps on going, right? And if you don't do it, it's fine as well, because apparently then there is no demand in this new data being produced. And this leads to this really nice outcome that, for example, Bitcoin block 0 looks the same all over the world. It doesn't matter if you access it from China, from Europe, from America, it's all the same. And actually, once we took this piece of data and store it and validate it through KYVE, you could delete it in theory from anywhere in the world, because you know that KYVE has independently and fully decentralized validated this piece of data and made it accessible. And so basically the proof of stake mechanism that lies behind it, of course it's very important to ensure actually that the stake you are working with is high enough, right, to securely support the other bridges. Let's say, for example, you're building an AMM, you're using KYVE's data as your financial data, AMM has a TVL of $1.5 billion. Then I think it's a fair question to ask, well, is a stake in this pool of like $10 enough, right? Well, of course, no, it isn't. You have to provide then a stake that's high enough to secure the data efficiently, and if not, our governance can always step in and ensures that pools stay paused. You can set up a minimum staking amount to make sure that you never run into any security problems, because worst case that's going to happen is this data stream coming in is pausing and then not exposing anything other to risk. So as I already walked a bit through our story in it, so we started out, right, being the bounty from Parity and KYVE. It's actually a year ago. It's quite an exciting journey. So we did a very big incentivized testnet with around 40,000 active participants. On that, it finished, I think, 2 months ago or 1.5 months ago. And now we're really just kind of paving the road to mainnet. We're looking for a mainnet launch in early Q4 this year to like ensure that we get this economic security into our system and then allow others to already build with it. We already have any major L1 and L2 as our partner, mostly for archiving purposes, so making sure that those networks can stay scalable, are able to, well, get some backups in case. So like, for example, we had a very early day talk, and it really didn't age well with Terra, where they were thinking about using KYVE as a decentralized quick sync for their nodes, where they say, actually, right now we are providing this centralized snapshot to node operators, but it's a fair question to ask as a node operator, why should I trust, right, like the Terra foundation? Actually, why should I trust any foundation if I'm running my node? Because you, as a node operator at the end, have to take the risk of running it. If you execute some incorrect trades or something, you're getting slashed in a proof of stake system with that, and you are the one responsible for that. So in a truly decentralized world, you always have to find a place to get your initial data from when getting the chain, because you cannot just sync. On Ethereum, I think it takes months, actually, if you would sync from other nodes to get your nodes up to speed. So it has to be something that is like kind of like a really service for that to it. And then, yeah, we also have, I would say, all EVM supported chains. We have Bitcoin. If you're a developer, you can play around with it. We have one GraphQL indexer out there. You can do cross-chain analytics if you want to. We also have some teams right now building out a SQL stack to access the data. And just in general, if you're a developer, I can highly recommend playing around with our data, seeing what you can do. It allows tons of use cases really around it, and should make everyone's working with data much more easy and much more accessible. Are there any open questions now? Doesn't look like it. That's good. All right, well, thank you very much. And yeah, if you want to kind of know more about KYVE, feel free to go to our app. It's app.kyve.network. You can play around with the current testnet. You can play around with the data there. Feel free to join us on Discord. We have a very active community of developers and node operators there. Or just, yeah, feel free to reach out. I will be staying here in front of the stage for a bit if you have any questions. So yeah, thank you for having me.